Hi, I'm Navdel, Application Scientist at Spectrodyne. In this video, we'll be going over peak filtering. This is a method to eliminate false positives in the data. Let's see how we can do that with this example I'm showing here. This is a 150 nanometer particle standard measurement in a C400 cartridge. You can apply peak filtering to both stats files and combined files. Navigate over to the peak filtering tab. Here you can plot any parametric scatter plot by using the Select Peak Parameter drop-down list and click View Scatter button. Let's take a look at what the transit time scatter plot would look like for this data. This will plot the diameter on the y-axis versus transit time on the x-axis. You can see that there are blue and red dots. The blue dot is an event that has been excluded by the applied peak filters. In this case, there are default peak filters that got applied automatically during the measurement run. The red dot is an event that was not excluded by the default peak filters or any peak filters. You can see the bead population well above the size limit for this type of cartridge, which is at 65 nanometers. Then the population has a certain range for transit time. As mentioned, the default peak filters have been applied for this data. Now, default peak filters are appropriate choices for standard measurement conditions and samples, but they may not be appropriate in all cases. In those cases, you can apply your own filters as appropriate. Notice the bloom you see spanning across broad transit times near the size limit for this cartridge type. This is a physical manifestation of the electrical noise false positives, and this is what we need to eliminate from the data. The safe peak filters for the chosen parameter are shown in the list on the left. Any filters that are applied to the currently loaded files are highlighted in blue. Each parameter will have their own list. Filter details can be viewed by selecting the chosen filter and click on the View button on the right. To apply and remove existing filters as desired from files in the currently loaded frame, we can use the appropriate action buttons on the right. The Active option will apply the action to the currently highlighted file. The All Loaded button will apply the action to all files in the currently loaded frame. Now, both of these will only apply to the selected parameter. The Clear All From option under All Filters will clear filters from all parameters. Now we're going to clear all default filters to apply our own custom filters. To create a new filter, use the Add button at the bottom of the available filters list. Choose one of the two options for the type of filter. The two options are linear or polygon. Linear will apply a filter bound with constant value, and polygon filter will apply a 2D user-defined polygonal boundaries. The drop-down list allows you to select from any of the 4 parameters. So let's create a linear filter in transit time. We can specify a descriptive name for the filter. So let's say we want to create a transit time filter from 0 to 100. And entering the bounds of minimum 0 and maximum 100, and click Create. The new filter will be added to the list, and you will need to find and apply this filter to the appropriate data. Plotting the updated transit time scatter plot, you can see now that due to the apply filter, anything above 100 microseconds in transit time will be excluded from the data, as noted in blue. Anything below 100 microseconds are included, which are labeled in red. Now let's create a polygon filter. First, we need to remove the previously applied filter. We're going to go over to the Add Filter option and select Polygon filter in the transit time. Specify the descriptive name for this filter. So for polygon filter, we have to click on the set boundary graphically. The transit time scatter plot will be shown, and from here you can create your own custom polygon shape. Remember, the filter is inclusive, so anything inside the polygon will be included, anything outside the polygon will be excluded from the data. Once you create a desired shape, hit the Enter key on the keyboard. You can still modify and adjust the shape of polygon afterwards if you like. Once you're happy with the polygon, hit Create and then apply the polygon filter to your data. This concludes our session on peak filters. I hope you find it useful. Further details are available in the Instrument Operation Manual, and if you have any questions, contact us at support@spectradynellc.com. More training videos are also available on our website. Thank you for your attention.